How do irrational numbers work in algebra? Have you ever wondered how some numbers just cannot be neatly expressed as fractions? This brings us to the fascinating world of irrational numbers. So, how do these numbers fit into algebra? Let's break it down. Irrational numbers are real numbers that cannot be written as a simple fraction or ratio of to integers. This means you cannot express them as p divided by q, where p and q are integers and q is not 0. Instead, irrational numbers have decimal forms that go on forever without repeating any pattern. Some well-known examples include the square root of 2, pi, and Euler's number. When it comes to algebra, irrational numbers behave much like other real numbers. However, they do requiring special attention since their exact decimal values cannot be fully written out. For instance, when simplifying expressions that involve square roots, if the root is not a perfect square, the result is irrational. In algebra, we often use symbols like the square root of 2 or pi to representing these numbers exactly, rather than using decimal approximations. Irrational numbers are a key part of the number system, sitting alongside rational numbers, which can be expressed as fractions. They play an important role in algebra because they allow us to find solutions to equations that do not have rational answers. For example, the equation squared equals to has solutions of plus or minus the square root of 2, both of which are irrational. In practical algebra, when simplifying expressions, we typically leave irrational numbers in root or symbolic form unless a decimal approximation is specifically needed. Adding, subtracting, multiplying, or dividing irrational numbers follows the same algebraic rules as rational numbers. However, the results may still remain irrational. You will often encounter irrational numbers in geometry and algebra problems, especially those involving lengths, areas, or constants like pi. Understanding irrational numbers helps learners grasp the full range of solutions in algebraic equations and the structure of the real number system. So, irrational numbers work in algebra as essential components of the real numbers that cannot be expressed as fractions. They can be manipulated symbolically and numerically within algebraic expressions and equations. By including irrational numbers, algebra can handle a wider variety of problems, ensuring that solutions are possible even when those solutions are not rational.